This is the weather patterns pretest, and this video will just be a read aloud of each of the questions in case you need help with reading the questions on your own. 1. An air parcel is an amount of air that moves together. On day 1 and 2, the air parcel above Anzac started with the same amount of water vapor in it. It rained at the end of day 2, but it did not rain at the end of day 1. What could have been different on day 2 to cause rainfall? A. The air parcel was cooler than the surrounding air on day 2, so it gained energy on day 2 but not 1. B. The air parcel was warmer than the surrounding air on day 2, so it gained energy on day 2 but not 1. C. The air parcel was warmer than the surrounding air on day 2, so it lost energy on day 2 but not day 1. D. The air parcel was at the same low temperature as the surrounding air on day 2, so it had low energy on day 2 but not on day 1. Next, we have a graphic. This rectangular box represents an amount of air that moves together. This is called an air parcel. Question 2. There were 2 rainstorms in Hatfield last month. Before Storm 1, Hatfield's temperature at the surface was 31 degrees Celsius. Before Storm 2, the temperature at the surface was 15 degrees Celsius. The temperature of areas surrounding Hatfield was the same before both storms. There was the same amount of water vapor in the air parcels before both storms. Which storm is likely to have more rainfall? Storm 1, the air parcel at the surface was warmer and had more energy, so it moved higher and it lost more energy. Storm 1, the air parcel at the surface was warmer and had more energy, so when cooler air from above came down, it lost more energy. Storm 2, the air parcel at the surface was cooler and had less energy, so when it moved higher, it gained more energy. Storm 2, the air parcel at the surface was cooler and had less energy, so with low energy, it remained near the surface. Next, we have another graphic. It says Dayton had 2 storms in June. Storm 1 had more rainfall than Storm 2. The temperature of the surrounding areas was the same before both storms. What conditions could have caused Storm 1 to have more rainfall than Storm 2? Before Storm 1, Dayton could have been cooler than before Storm 2 and windy. Wind pushed the cooler air parcel even higher, and the air parcel gained more energy. Cooler than before Storm 2 and windy. Wind caused the cooler air from above the air parcel to move down, causing the cooler air parcel at the surface to lose more energy. Warmer than before Storm 2 and windy. Wind pushed the water vapor out of the warmer air parcel. Warmer than before Storm 2 and windy. Wind pushed the warmer air parcel even higher, and the air parcel lost more energy. Question 4. The air temperature of Ostleys is higher than the air temperature of Eastbrook. What is the main cause for the different air temperatures? More energy from the sun is transferred to the ground in Ostley than in Eastbrook, and that energy is transferred to the air above. More energy from the sun is transferred to the air in Ostley than in Eastbrook, and that energy is transferred from the air to the ground below it. The heat from the center of Earth transferred more energy to the ground in Ostley than in Eastbrook, and that energy transferred to the air above. There was less wind in Ostley and more wind in Eastbrook. Wind moved the energy out of the air in Eastbrook. More energy out of the air in Eastbrook than in Ostley. Question 5. Nasha left a hot bowl of soup in a cool room. Her friends tell her that her soup will get cold if she forgets to eat it. But how cold could it get? Only a little colder. It started out much hotter, so it will stop cooling down before it reaches the same temperature as the room. Only a little colder. It will stop cooling down when its temperature is about halfway between its starting temperature and the temperature of the room. Only as cold as the temperature of the room. It will stop cooling down when it is exactly the same temperature of the room. Colder than the temperature of the room. It will keep cooling down for as long as she leaves the room. We have another graphic here. Air parcel 1 is warmer than the surrounding air. Air parcel 2 is the same temperature as the surrounding air. Air parcel 1 and 2 started with the same amount of water vapor in them. Question 6 is asking, which air parcel will have more rainfall and why? Both air parcels will have the same amount of rain. They will have the same surrounding air temperature, so the same amount of water vapor will fall as rain. Air parcel 1 will gain energy from the surrounding air, which will cause more water vapor to fall as rain. Air parcel 1 will lose energy to the surrounding air, which will cause more water vapor to fall as rain. Air parcel 2 is colder than air parcel 1, so more water vapor will fall as rain. And lastly, our free response question has this graphic. It says the temperature of the areas surrounding Santa Carina before each storm was about 13 degrees Celsius, and there was the same amount of water vapor in the air. We have before storm 1, 2, 3, and 4. Notice that inside of each air parcel, it identifies what the temperature is. We have 30, 15, 30, 15, and the degrees on the outside of the air parcel are as follows: 13, 13, 13, and 13. And in storm 1 and 2, we see that there is wind and no wind in 3 and 4. Given this information, which storm do you predict will have the most rainfall and why?